Just as a brief overview, with Microsoft, you typically don't associate us with agriculture, but at the core, what we're looking at is how technology can help uh, solve some of the hardest problems. It's not a solution, but it could be a very powerful enabler in helping solve some of the hardest problems that we are facing. And in particular, the world's problems is something that many of you in the audience are very well aware of. We need to grow more food. We need to grow not just more food, but good, nutritious food. And we need to grow this food without harming the planet. The soils are not getting any richer. The water levels are receding. There's climate change. So given all of these challenges, how do you grow good, nutritious food to feed the planet? So one of the ways in which we think we can get there is if you make the entire food value chain more data driven, all the way from input companies to equipment companies, growers, food processors, warehouses, the supply chain logistics companies, all the way to the retailer. If you could make the entire food supply chain more efficient, more data driven, it could drive a lot of efficiencies through the entire food and agriculture value chain. But it is not just that. If you could start sharing the data across the entire food value chain, this could lead to new business models. This could lead to new efficiencies. For example, new business models such as around sustainability, around nutrition, around track and trace. So towards that at Microsoft, for the last 9, 10 years, we've been looking at how do you enable such a data-driven agri-food system where you can then start capturing the data, and then on top of that, bringing artificial intelligence to unlock new insights. And as we've been doing that, over the years, we've released what was previously FarmBeats as Azure Data Manager for Agriculture. I was on stage earlier this year where we announced this capability. This is a new product from Microsoft, which was previously FarmBeats. It was in public preview. We announced a partnership with Bayer Corporation, where Bayer's announced its Bayer Agri-powered services on top of Azure Data Manager for Agriculture. We've open sourced farmvibes.ai, which I talked about in the previous talk that Parmesh talked about, which is we open source farmvibes.ai, essentially over 65 different AI workflows, which is now being used by several organizations, including Accenture, which is now building solutions on top of Azure Data Manager for Agriculture, leveraging farmvibes.ai and building solutions for various agriculture organizations. We are continuing to push on the research side. We believe that despite what we are doing, we are still scratching the surface in what could be possible with this concept around data-driven agriculture. We are working on things like connectivity. How do you use small IoT satellites to connect farms? We are working on new ways to measure things on the farm at very low cost using, for example, phones or Wi-Fi. There's a lot of work on multimodal AI, some of which I touched upon in the last talk. But today I'll talk about the topic of today, which is on generative AI and LLMs for agriculture. So in this talk, I'll first talk about some of the common use cases which you currently know about, which can be done using retrieval augmented generation. This is the most common way in which you use some of these generative AI models. Then I'll touch upon a new technique, which is called fine tuning. That is, can you actually, instead of just taking the model as is and bringing your data in, can you actually tweak the model? And when does that make sense? And then I'll cover with some of the new work on multimodal GPT as well. So, when we think of co-pilots for agriculture, every stakeholder across the food value chain would benefit, food agriculture value chain would benefit from co-pilots, be it the farmer, the agronomist who wants to communicate with the farmer, the policymakers who are making policy documents and they want to make it more accessible to the farmer, the banker who wants to communicate with the farmers about loans, about insurance, what the farmer should be doing, the supply chain individuals who want to, again, coordinate with the farmers. They have their own standards, to an ag retailer who wants to help the farmer with with purchasing decisions, a data scientist who again wants to do workflow automation for different agricultural workflows, to a food manufacturer, and so on. There are many more. And each one of these, even if you're thinking of it as a business, I know many of you might be coming in from a startup, from the startup world, you're going to benefit a lot from using using some of these co-pilots. One of the things we leverage heavily when we build these agriculture use cases is what I talked about last time, which is farmvibes.ai, where what we do is we take data from different data sources And then we use that data to create insights. Like, for example, what's happening in a farm, say in Africa right now, say in Kenya, you want to give a polygon and you want to know what's happening in a farm. So what we've built is what we built through this agriculture copilot is basically what you do is first you give it, if suppose a farmer asks a question, what is, say, what is the expected yield in my farm? For example, here the farmer can say, please analyze the summary of health of vigor in my crop over the wheat growing season in 2022 in Farmington, Washington. The thing we do is, once for every farm that we monitor, we store all the data corresponding to that farm in what we call a farm context. So through Azure Data Manager for Agriculture, we store all the data for the farm, and then we periodically run workflows. Say, for example, what is the satellite indices for that farm? What is the tractor data for that farm? We use that to then create workflows, and those workflows are stored as farm context in the cloud. So when a farmer asks a question, say, what is the health and vigor of my crop? We augment this prompt with additional information about that farm that is stored in the cloud through these FarmVibes.ai and Azure Data Manager for Agriculture workflows to then ask GPT-4 to come up with the answer of what it is. And it not only gives out the answer, it would plot it in terms of graphs as well, where you can then ask questions. What do these NDVI values mean? What should I be applying in the farm? You could ask questions such as, what products were applied in my field in the year 2023? How is the health of the crops and seeding, and so on? These were some of the questions that were given to us by a smallholder farmer here in close to Microsoft campus. And these are some of then he gave us 25 questions, but 21 of the 25 questions, when we used this technique of retrieval augmented generation, the farmer then ranked our questions, and for 21 of the 25 questions, he gave it a 5 out of 5. For the remaining, he gave it a 3 or a 4. You could then ask budget-related questions as well. For example, what should I be doing? I'm seeing this particular weed in the farm. Should I be applying pesticide? If I apply this much pesticide, how is it going to impact my bottom line? The other thing which I briefly mentioned last time as well, we did use GPT-4 to, the question we asked was, can we use GPT-4 to answer agricultural exams? And we looked at different exams. One was the Certified Crop Advisor exam. This is an exam an agronomist, anyone who is an agronomist in the US has to take this exam to be qualified as an agronomist. And the question we asked was, can we use GPT-4 to pass these exams? And as you can see, with RAG and context, the answers are, the score was pretty high. It got 93% grades in this Certified Crop Advisor exam. We did it not only for multiple choice questions, but in Embrapa in Brazil, we asked it long form questions, and GPT-4 got 84% grades in these exams. In India, interestingly, the organizers not only publish the scores, they not only publish the results, they also publish the scores of the top 100 people. And the GPT-4 got 79% grades in this exam, and the number one human in the exam got 78%. So GPT-4 would have topped the exam, this particular exam in India. But the thing is, so one takeaway from this slide is not that GPT-4 could be an agronomist replacement, but it could be a very powerful agronomist co-pilot. That is, agronomist has to remember a lot of information about agriculture and the farm. Here, the agronomist has a consultant, has a co-pilot they could consult with when making recommendations to growers, and this is completely unbiased. The thing is, GPT-4, despite that, also makes mistakes. Suppose the question was, who was the advocate? This was one of the questions in the India exam. Who was the advocate of the Marthandam Rural Development Program? And GPT-4 said the actual answer was Spencer Hatch, but GPT-4 thought this was an exam in India, so it came up with the most likely answer. The only Indian in the list is Mahatma Gandhi, so it says the answer was Mahatma Gandhi, but the answer was Spencer Hatch. So what that means is that, GPT-4 does make mistakes. So we need to come up with other ways to reduce the mistakes that GPT-4 makes. And one way in which we think we can, one of the techniques we explored was that of fine-tuning of GPT-4. So so one particular example, suppose, why do we need to do it? Suppose the farmer question was, this is in the US, suppose the farmer asked a question, what are the best times to plant trees and shrubs? If the farmer asks this question, the answer varies depending on where the farmer is. If the farmer is in Georgia, the answer is in the fall. If the farmer is in Arkansas, the answer is in spring and fall. If the farmer is in Connecticut, it's during late winter or early spring. If you ask this question to GPT-4 or Bing, it just, irrespective of where this question is asked for, it just answers fall for all three states. And that's something that we need to go explore further. And what we said was, what if we fine tune GPT-4 to give location specific answers? That is, suppose it is a farmer in India or in Kenya, and you can give location specific answers based on where the farmer is right now. So we went about building an entire fine-tuning pipeline for GPT-4. This happened before any of this capability was announced. We've been working on this for several months. What we did was we started by taking a high-quality agriculture data set from US, from Brazil, and from India. From the US, what we did was we took all the data from different data sources, from USDA, from different extension agencies. We worked with different universities to accumulate a very high-quality data set. We did the same with Brazil with a lot of our partners. And in India, it's a smaller data set, but we are continuing to expand on this. But what this is a very high quality data set. The next step you need to do to fine tune is, especially because you need to instruction fine tune, it is not enough to just give it PDFs. You need to take the PDFs and convert the PDFs into questions and answers. That is a PDF. All the data in a PDF needs to be captured in terms of questions and answers. Once you do that, then we push it to fine-tuning the model. We fine-tuned various models. We looked at Llama 13 billion. We're now looking at 70 billion as well, GPT 3.5 and GPT-4. And then we use the answers to then come up with an evaluation, which we then rank. How well does any of these fine-tuning models compare to the base models and to RAG? We did all of this and we compared this to RAG as well. That is, instead of, once you have the data set, what if you could create the embeddings and use, again, either the raw GPT model or the fine-tuned model to see how well do these models perform. This is just some of the data set that we had from US, Brazil, India. The next question was, how do you take these PDFs and convert it to questions and answers? We used, first thing you would do, if I give you a PDF and say, hey, I want to convert it to question answers, the simplest way to do it would be to say, hey, I'll just use PDF to text, and then use GPT-4 to generate the questions, and then use GPT-4 to generate the answers. This is basically, if given a PDF, you could just feed the PDF to GPT-4 and ask it to come up with questions and answers. The thing was, it doesn't capture all the information very well. The next thing we tried was, what if we just extract the metadata and then using another tool that exists, and then use that to generate questions, and then use the metadata to generate questions and use that to generate answers. We got better coverage, but the answers were very terse. Instead, the approach we ended up using was we use this, again, tool to extract the metadata. We then use GPT-4 to generate the questions, but we use RAG to generate the answers, which became our high quality data set that we end up using for this purpose. The next stage was fine-tuning. Fine-tuning is a more intensive step. We did both full fine-tuning for Llama 13 billion, but for GPT-4 and 3.5, we used LoRa-based fine-tuning. This was fine-tuned for 4 epochs. We ran on Azure Machine Learning. We fine-tuned on 56 A100s for 36 hours, and the batch size was 256. The Llama 2's the fine-tuning was done on 8 H100 cluster that we used for that. And finally, to evaluate how well some of these tools perform, we use GPT-4 based eval. One of the interesting things here was rather than asking GPT, so the way we worked with this work was we fine-tuned the model. We had a set of evaluation questions, which we gave. This was manually curated evaluation questions, which we gave to the fine-tuned model GPT-4. The answers that came out, we compared it with the reference answer, which was manually curated. And instead of saying, hey, give it a score of 1 to 5, if we gave it scores of using qualitative metrics instead of quantitative metrics, the performance was much better. So now that I've talked you through the fine-tuning pipeline, once you bring in the data, this is another thing that you could do. We then started comparing for a Washington State benchmark set. So this is for Washington State. We looked at how well does RAG perform to how well does fine-tuning perform for Washington State data set. The key takeaway here, if you look at the bottom right, is if you use both RAG and fine-tuning, you get the best results. The results are 86% accuracy for this particular data set. If you only use RAG, it still goes a long way for example, for 80, up to 80% accuracy if you just use RAG. The other challenge here was that Llama performance actually went down with fine tuning. Basically, it's a small model. If you give it very high, a lot of data, the small model performance actually degrades. But the key takeaway here was that if you use both fine tuning and you use retrieval augmented generation, the results are actually quite good. But for most cases that you're using right now, RAG might work quite well as well. But the part where fine tuning really shines is when you're looking to extract new information, when you're looking to extract new knowledge which did not exist before. So here, so for example, the scenario that we were interested in was, suppose there's a farmer in India that asks a question. The advisories in India did not have an answer to that particular question, but you might find an answer to that question. It might say, hey, the conditions in this part of India map very similar to, say, the conditions in Brazil. So if you're looking at answers, this is what we did not find in India, but you might find in the advisories in Brazil. So to quantitatively study that particular scenario, what we did was we looked at 1,000 evaluation questions that we removed from the fine-tuning data set. What these particular, so for example, this was again done only for the US. We looked at all the 50 US states. We looked at questions that were similar across multiple states in the US. So for example, when should I plant corn? If this question is similar across multiple states, what if we remove some of these questions from some of the states? So we kept 3 questions and we removed the rest from the other states. And then we fine-tuned the model. And then the question we looked at was, how close to the actual answer can we get? Can GPT-4, fine-tuned GPT-4, learn the answers to questions on which it wasn't trained? So here what you're seeing is GPT-4 with fine-tuning was able to get somewhat similar answers. The result, the performance went from 47% to 72%. The last column that you're seeing is kind of the upper bound. The best we could have done is if the data was already present in the data set, which was 74% in this case. But with fine-tuning, we are able to learn a lot of this missing knowledge. This is something we are actively continuing to pursue because in agriculture, we believe a lot of these advisories don't exist. And the more we are able to learn, the more we'll be able to bridge and come up with new information, new advisories for different places around the world. Using this, we can also kind of democratize knowledge. That is, as new knowledge is being discovered in different parts of the world, we can then disseminate it and disseminate it to the parts where it might be most relevant. To summarize this part of the talk, one of the questions you can ask is, suppose you get a data set. Many of you here might have very proprietary data sets. The question you might ask is, what should I use? Should I use RAG? Should I use fine-tuning? When does what work better? So these are just different metrics where with RAG, your prompt size increases. So that increases cost. So suppose you ask a question, what is the yield in my farm? That would be augmented with all the other things. What is the yield in my farm would then be augmented by, I'm a farmer here. This is what I have done. This is the advisory information. The prompt size becomes pretty big. With fine-tuning, your prompt size stays small. The cost of the output with RAG, it's more verbose. With fine-tuning, you can actually make it very precise to what you want to recommend. The initial cost with RAG is low because you're just taking the big data set and creating an embedding out of it. With fine-tuning, the initial cost is high because you need to get these GPUs for long periods of time to take this large model and fine-tune it, customize it to make it work for your scenario. But the accuracy-wise, both of them are quite good, RAG as well as fine-tuning. But if you want to learn new knowledge, RAG is essentially constrained by the data you give it. With fine-tuning, you can start learning new skills in the domain. So in our case, the fine-tuning here was to give location-specific answers, but you can look at various other scenarios where fine-tuning might be helpful. But depending on your scenario, you could use either RAG or fine-tuning. And if you're interested, do reach out. I'd be happy to work with you to decide which of these approaches to take for your particular data sets or for particular scenario. Finally, just briefly touching on multimodal GPT, this was work I did with Rikin, who's be talking after me. So, with the question here was with multimodal GPT, for example, what you could do is if you take an image, it will not only tell you what is in the image, it will tell you why it thinks what's there. For example, here the question was, what is this worm? I'm a cotton farmer in India. Is this worm harmful? It'll come up with the answer. This is a cotton bollworm, and why it thinks it is that particular image. Here, this is very you can hardly see the worm here. But even GPT-4 starts by saying that it is not very confident. It says, without a clear image, I don't know what it is. But then it goes into the details and says, based on the location of the flower and appearance, it appears it is the cotton bollworm. In this case, it was right. Another very interesting use case was this particular one, where a farmer asked a question, I'm a chili farmer in India, what is it that I'm seeing? Even though the initial labeled answer said that it was root rot, GPT-4 correctly said that it was root knot nematode, which we then confirmed, Ricken confirmed with the agronomist to say that it is actually a root knot nematode. This is another use case of a friend of mine who's here in Seattle. He actually has a farm in Karnataka. His question was, I'm a farmer in Karnataka in Vijayapura district. I planted Baidagi chilies in July. It's super low rainfall this year. It has been irrigated using sprinklers. I'm seeing these small holes in leaves. This is a real world use case that this year he had. He asked, what is wrong with my plant and what is causing it? First, GPT-4 gives very generic answers. It says flea beetles, leaf miners, slugs, and so on. You give it another image and it starts getting to the right answer. It says, well, based on this additional picture, it appears that your plants may have bacterial leaf spot. You give it another one and it says, yep, this picture confirms it's actually bacterial leaf spot. And you don't only stop here, you then ask it the question. You could go to Bing Chat and say, hey, what should I do to control bacterial leaf spot on my chili plants in Karnataka? It will go and then it will look at a resource in India. It could do better than the Hindu, but at least it's looking at a local source. And it says, based on this, if you have bacterial leaf spot, you can then use spray agrimycin and come up with a particular recipe of what you should be spraying if you have an infection in July and September. So you can see how you can, using generative AI, you can take the entire pipeline and come up with more local, much better recommendations for what the growers should be doing. So one question I want to conclude with is, many of you might be asking the question, okay, how do I start using all of these tools that I've been talking about? So if you're in Azure, this is the Azure AI stack. One of the key parts of the stack is this Azure OpenAI service. So what we've done, as many of you know, Microsoft has partnered very closely with OpenAI. All of the compute of OpenAI is done on Azure, and we partner very closely with them, not only on the infrastructure, but also on taking the solutions that OpenAI has built to different to the bigger customer base, be it enterprises or consumers. And as part of Azure OpenAI service, we've exposed multiple APIs. We're bringing these large foundation models with GPT-4. We've also announced a partnership with Llama, where we're bringing that to customers as well. The reason to use Azure OpenAI is then your data stays within your tenant. Your data is not used to train the larger model. Your data stays private with you. It is not being exposed. You keep your IP with you if you're using the Azure OpenAI service. And it can be used for many such use cases, like, for example, of course, writing assistants, reasoning, summarizing, chatbots. But for example, the agriculture copilot that I showed initially in the beginning of the talk was built on top of Azure OpenAI. And the other benefit of using Azure OpenAI is that responsible AI tools are built into Azure OpenAI. By responsible AI, I mean things like fairness. Is it going to be fair? Is it going to be explainable? Coming up with counterfactuals, doing causal analysis, coming up with a responsible AI scorecard, basically making your solution more, having the right guardrails, making sure that it has the right security, the right trade-offs, the right responsible AI principles built in. Right now at Microsoft, for any product that we announce, right from the beginning, we start thinking of the responsible AI principles. But if you're using Azure OpenAI, you have these capabilities as part of your solution as well. So if you're building a solution, you can start using the tools to make sure that that your solution is built with responsible AI kept in mind. So to summarize my talk, we believe Gen AI is this big step change in agriculture. It helps it helps democratize a lot of data. It helps bring a lot of information and make it available to farmers. And right now, we are still at the beginning, both with generative AI and multimodal use cases of generative AI. You can either use, and in this talk, I talked about different ways in which you could start using generative AI tools right now. If you have just text, you could use either retrieval augmented generation, which is what most people use right now. You could also start looking at fine tuning these large models, especially if you have huge amount big data sets and you want to make you want to either learn new information or you want to customize it to learn new skills. But all of these are just different tools that you have available to use right now. And you can start using it with Azure OpenAI. One of the big reasons, I'm not a sales guy, but the big reason I'm trying to propose either Azure OpenAI or any such tool is when you build a solution, you should start building solutions keeping responsible AI principles in mind. You don't want a solution to have a bias. You don't want your solution to start behaving in ways you did not expect it to behave, because that's one of the things we have to be careful of when we are using any of these large models. So with that, I'll conclude my talk. Thank you, Parmesh, and everyone else in the audience.
Thanks a lot, Ranveer. I learned a lot of things myself. What are the foundational aspects? What's the backbone? What are the different approaches being? And what I'm encouraged is that there is a continuum. You could take the text and you could convert it into analytics and advisory, or you could then upgrade this as you go along if you have data and all that. And then multimodal GPT is, I think, the most exciting part of this, where farmer gets real-time advice in real time, rather than waiting for an extension agent to descend from heaven, and who comes after the pest is already long gone. So I think potentially this is very powerful, and I think we are still scratching the initial stages of it. And I think it's very good. It's a good tutorial on what this generative AI is about. And I think once we play this recording in a YouTube video, this will become very popular, what you have been saying for the last 15 minutes. Many thanks, Ranveer, for really putting this in perspective. I would now go to my friend, Rikin Gandhi, who is also a collaborator in many countries and many programs which I have worked on in India, Kenya, Ethiopia. And I would and encourage Rikin to just share the experiences which they have recently tried out in a chat GPT for farmers in India, and what they're doing and all the places. Rikin is always at the last mile and delivering products and services for smallholders, which is my concern. Is this for smallholders? And does it work for smallholders? And Rikin, over to you. And please put your questions in the chat as you have been doing for Ranveer. And we will pick some of the most important questions at the end. We will extend this session by 10 minutes since we started late. So we'll close at 11:10 if you guys stay. And I will see the numbers on the right-hand side. And if people are staying, then we'll go 10 minutes further. Over to you, Rikin.
Thank you so much, Parmesh. And yeah, it's obviously such a great pleasure to be here with you, a collaborator for so many years, as well as Ranveer, who we've also collaborated with for many years, including for this particular work, which we are doing to leverage the power of generative AI to support increasing the efficiency and impact of agricultural extension programs. Just to give you a little bit about the journey about how Digital Green got to this work for other peers who are on today's call. We started this journey back in 2006, where we were looking at the existing ways in which agricultural extension was being practiced, primarily popularized by the World Bank in the 70s in Asia, with a model called training and visit, but also newer forms of extension like farmer field schools, wherein there are large cadres of extension agents who are going to conduct field demonstrations or other types of training programs for farmers, and where they incur a significant cost with regard to bringing in experts to conduct these kind of sessions. And then a small percentage, 10-15% of farmers going back and applying these practices at home. And so what we found is in some of these controlled trials with external collaborators like IFPRI, JPAL, IPA, that this often can cost about $35 US to get one farmer to adopt one new climate smart practice, or the like. And so when we started this work at Digital Green back in 2006, we were actually also part of Microsoft Research in India in a group looking at technology for emerging markets. And we had this academic question, which was, how can we leverage digital technology to improve the speed and effectiveness of existing extension systems, not to create parallel systems or to disintermediate existing grassroots level networks of extension agents and farmer groups, but rather to build on the social networks of farmers and extension agents themselves, since these are often the most effective way in which information about what crops and livestock people are having and how they're managing them is being shared today. So when we started, we focused on the use of videos that would be produced by and for farmers. We've done this in the auspices of a number of World Bank programs like the National Rural Livelihood Mission in India, the Agricultural Growth Program in Ethiopia, and there are these large networks in places like Ethiopia of about 70,000 development agents who are conducting various types of demonstrations of improved practices amongst farmer development groups and the like. And what we've been doing is using videos by and for farmers to share practices in the form of testimonials and demonstrations amongst these existing groups of farmers that are already coming together on a fortnightly basis, and where these extension agents are using a mobile projector to show these locally produced videos in local language, and where the communities are able to share their own questions, their feedback, and their extension agents are able to record what are these communities interested in, what practices do they ultimately adopt afterwards. I'm going to be able to show that we can reduce the cost per adoption of these practices from $35 to a tenth of the cost to about $3.50 and increase farmer incomes by over 20%. This network of government extension programs primarily, but also civil society, NGO, and even in some cases private sector extension programs that we work with, has led this approach to scale to more than 5 million odd farmers, primarily India, Ethiopia, Kenya, but also in other parts of South Asia and Sub-Saharan Africa. But that's only because we've layered on top of these existing in-person extension agent networks, 54,000 extension agents who have mobilized various types of farmer groups, self-help groups of women, and the like, on top of which this use of videos has taken place. What we also realized in our journey was that producing and showing these videos was great, but for certain types of practices, especially as it related to soil fertility management, irrigation management, and also feed management for dairy cattle, there's a need for this content to be even more localized, not just at a district level in which these videos would be produced and then the villages in which these videos would be shown by these extension agents, but there was a need to get them even more customized in a more site-specific way based on agroecological parameters, terrain maps, soil conditions, and the like. And so we embarked with a number of our government extension partners to set up, in some cases, registries of farmers and extension agents that would include data about their names, locations, gender, crop, livestock mix. In some cases, some of our government extension partners already had these kind of systems. In other cases, we had to set it up afresh. But then, of course, this is extremely sensitive, personally identifiable information. And so there was a real need to protect that data, to say that these individuals should be able to consent to determining how that data could be shared. And then in return, an agricultural research organization like from the CGIAR or from a domestic research center could take those parameters and then generate a more site-specific recommendation. And that's what you're seeing here in this Telegram bot in Ethiopia. Extension agents are able to consent to sharing their information, and in return, from CIAT, a CGIAR center, are able to get site-specific fertilizer recommendations in the form of both text, but as you can also see here, a map and an associated video. and then are also able to give data and feedback back about how many farmers did they reach, how many farmers actually applied these recommendations on their field. And we've been able to show in collaboration with CIAT how the more generic type of recommendation of applying 100 kilos of urea in a blanket way across the whole country has become a lot more tailor-made and is both obviously beneficial from an environmental point of view, and for farmers, it results in this increase of about 38% yield improvement over a more generic recommendation. The latest sort of version of this, which is building from Ranveer's presentation, is to leverage the power of generative AI so that this whole combination of what we've been doing over the years of producing videos and showing videos and gathering data about who these extension agents and farmers are to provide these more site-specific or customized recommendations can all be built into a more user-friendly, conversational user experience for especially extension agents. As Ranveer said, the whole idea here is not to replace agronomists, but to really aid them as a co-pilot or as an assistant, so that as they are trying to build up their own skills and they're trying to triage the various questions and issues that farmers have, that they have a ready resource that isn't just like the generic ChatGPT kind of information, but is the location-specific information that is produced by fellow extension agents, by fellow farmers in their vicinity, and that they can also be able to share feedback against. And so we've been leveraging these tools of GPT, as Ranveer mentioned, and also some of this multimodal functionality so that these extension agents can ask questions and also get nudges in some cases for these more site-specific recommendations. As they're interacting with these chatbots, data is also being developed about who these extension agents are in a more dynamic way, rather than just a one-time data collection exercise for a registry, and then being able to tailor make how they interact. And what we're seeing is we can see the potential of reducing the cost per adoption and reach of engaging these extension agents and farmers by another 10x, right? We had taken the conventional extension system from 35 US to 3.5 US with our video approach. We see the potential for taking this even further. There's still evaluations that need to take place to rigorously evaluate that, but we're seeing that potential. The way that this is set up is very analogous to what Ranveer mentioned in terms of using a RAG-based approach, retrieval augmented generation, wherein a combination of the existing library of videos in these local languages featuring farmer testimonials and demonstrations, as well as other types of data sets like weather and market info that many of our government extension partners are gathering, is basically curated into a knowledge base or a vector database representation. Some of these transcriptions and translation processes are leveraging tools like Bhashini in India, which is a Government of India program for creating various types of speech-to-text translation services, as well as other service providers. And there, of course, is a need to curate and moderate that transcription and translation process, since it's not 100% reliable. And so there is still manual processes to review and edit that content before it gets into that vector database representation. And then similarly, on the query side, when an extension agent is using WhatsApp or Telegram, which many of these extension agents already do, to be able to share information with each other or with their supervisors or the communities that they serve, then they're able to query this knowledge base in local language, speech or text, and again, have that translated and transcribed, so then a match can take place between the query and this knowledge base. And then in return, they both get the response that they are interested in, which again is this very domain and location-specific knowledge base of approved content from our often our government extension partners, but then also get a synthesized response that directly answers their queries. And as I also mentioned, as they're interacting with this bot, we're able to see how well the bot functions in terms of its success rate, and the feedback that the extension agents provide in terms of thumbs up, thumbs down. And we're also able to learn more about who these extension agents are, what they're interested in, and for the farmers that they're serving. And here's like an example of the kind of data that we're able to track in a more automated way as extension agents are interacting with the system. As you can see here, this was a deployment of this bot in the state of Bihar under a World Bank supported program run by the government of Bihar called the Bihar Rural Livelihood Promotion Society, or Jivika. And you can see initially, the bot was pretty unsuccessful. It had about a 60% or so lack of information error rate. But over a 45-day period, we were able to close that gap. And that was a combination of both the AI model learning from the feedback from these extension agents and us working with Jivika, this government partner in Bihar, to introduce additional content that would address these common questions that these farmers or extension agents were asking about. And what we were essentially able to do was to tighten the loop between producing and sharing information with these extension agents in a much more faster and dynamic way than what we could have ever done through our more conventional way in which videos would be produced, videos would be shown on a mobile projector, data would be collected, and then perhaps somebody would review it to then produce a new video to address frequently asked questions. You can see here in just a 45-day period, we were able to track how the changes to this bot and the content that was going into the bot could really be responsive to what the expectations are of these extension agents. And just like Ranveer said, we're also gathering all these commonly asked question and answer pairs for these extension agents in their local language, voice, and text form, so that the bot can be trained to better address what their expectations are. Let me just show a quick video. I hope the audio comes through for how this is actually being used by a village resource person in.
आलू में झुलसा रोग लगा है, उसका दवा बताइए। आलू में झुलसा रोग फाइटोफथोरा इन्फेस्टेंस नामक फफूंद संक्रमण के कारण होता है। ये तेजी से फैल सकता है और आलू की फसल को काफी नुकसान पहुंचा सकता है। आलू में झुलसा रोग की रोकथाम और उपचार के लिए यहाँ कुछ उपाय दिए गए हैं। आलू की प्रतिरोधी किस्में जैसे कुफारी पोखराज, कुफारी लालिमा, कुफारी काचन, राजेंद्र आलू 1 और कुफारी सिंदरी लगाएं। पहले जब हम फील्ड में निकलते थे तो मुझे बहुत समस्या होता था। किसान दीदी जब हमसे कोई सवाल पूछते थे कि हाँ ये सब्जी के खेत में ये कीड़ा लग गया है तो इसका जवाब दीजिए या बताइए दवा का नाम, तो मुझे बहुत परेशानियां होती थी दवा के नाम बताने में। अभी जो चैट वो आया है उससे मुझे बहुत आसान हो गया है। अब मैं खुद बोल के भी और लिख के भी मैं ये सवाल कर लेती हूँ और दवा का नाम बहुत जल्द आ जाता है। बोलकर भी उधर से जवाब आता है और वीडियो से भी जवाब आता है और लिख कर भी आता है।
So that was a village resource person in
Bihar,
under this Bihar Jivika program that I had mentioned. And these are just some of the emerging use cases. It's still obviously early days in general. So there's a lot that we're learning about how to build these type of systems and how people want to use them in the field. But these are some of the emerging use cases that you can see from extension agents. So for example, a lot of extension agents are using this for their own self-learning and development, since they often have variable degrees of orientation and training themselves. Then many extension agents use this when they're in group meetings, like in a self-help group meeting of women, and where there might be a question that they can't answer, they use this bot to answer those kind of questions. Or when they're in the field, directly with a farmer, they use this bot to be able to, again, triage the questions that they have. And we are deliberately focusing on the use of this chatbot for extension agents as an assistant for them. And also because we recognize that we're still in a calibration process of this whole system to ensure that it's responding in a relevant and a high quality way and not having hallucinations and the like. So we're not trying to go directly to farmers, but in some situations, we have seen some of these extension agents wherein the ratio of extension agents to farmers is very low, that they have shared the the bot with farmers to be able to self-service some of their common questions and then be able to escalate issues that the bot is unable to support them with to their nearby extension agent. Everything that we build, we're an NGO, nonprofit, so we build everything that we can in an open source way, so that other organizations, including our government partners, but perhaps even some of you on today's call, can add your content or service into this type of chatbot, or can also leverage the kind of tools that we're building on top of some of these proprietary large language models in a way that you can then create your own bot without having to reinvent the wheel or having to, build as much technical capacity in-house. The last bit I wanted to mention was that also similar to what Ranveer shared, what we've mostly focused on so far has been around this RAG pipeline of taking in locally relevant knowledge, including like the type of videos that have been historically produced, and then building a simple conversational user interface that people can then just ask questions and get queries answered again against that location-specific knowledge base. But what we're also recognizing is that sometimes there's also a need for fine-tuning of a model in an agricultural domain-specific way. Some of the examples of why we're seeing this to be true is that for certain types of queries, the extension agents might ask them in a very high level or vague way. They may ask, my crop is browning. And there might be a need to decompose that query that they've asked into its components of what crop are they referring to, at what maturity stage is it, what could be sort of the causes of browning, to help resolve the ambiguity that might exist in the first stage query. And that's also where multimodal type of input of being able to also take in photographs also can have a huge value, since being able to specify a query in a text or voice form can sometimes be challenging. And then similarly, like we're also seeing value in perhaps creating a digital public good of a fine-tuned large language model for our agricultural domain. We don't think any one organization, Digital Green or anyone else, should be the owner of this. It should ideally be something that we collectively as a agricultural sector see as a pre-competitive interest of all of us to invest in developing and have a governance structure of perhaps country governments and farmer organizations to say that there's a need to build basic reasoning capabilities in the large language model to understand some basics around how things like crops might be associated with companion crops, weather, soil conditions, so that we can get these more national or partner-specific RAG-based chatbots to be performing in a more responsive and relevant way. So far, our work, we've scaled it now to 3,000 odd extension agents with various government and cooperative partners in India, Ethiopia, and Kenya. And we're about to launch a whole of country program with India's Ministry of Agriculture in February. I did want to just show real quick a demo of what this can enable so that you can sort of see it in real life. So this is, I believe you should be able to see this, but you can see how in this, I've submitted a picture, right, to this particular farmer.chat that I've kind of customized as a custom GPT. And I've given it a very simple question about what is wrong with this farmer's field. I've not even specified what we're looking at. And you can see that, yeah, it identifies that it's a paddy field, that there could be some issue about these discoloration that it's seeing. And then it asks for a more closer image of it. And then I do submit like basically a more an image of some tillers of that particular affected crop. And again, I just say like, does this close-up help? And you can see that it is able to get more specific with identifying what it could be as a pest control measure. And then I ask more specifically, like for addressing this plant hopper issue in this paddy field. What could I do about it? And then you can see here it's pointing me to a Nemastrum botanical pesticide preparation video, which is linked to like the library of videos that one of our NGO partners in India has produced on Nemastrum. And then you can see I can ask it a question about what are some non-pesticide management NPM shops where I can buy such inputs from. And you can see it then gives me for Gaya district in Bihar some specific shop agripreneurs where I can purchase it. And I can do this not just in English, I can also ask the same kind of questions like what video is here that relates to this practice. And you can see that it also pops me over there. And the way in which to set this up is actually like, it might seem like very complex and technical sometimes when we show these like PPTs, but it's amazing how like also some of the user interface of creating these bots is also very intuitive, even for like totally non-technical people. So as you can see here, the way that I configured the setup of this bot was I just told the bot that you are an AI assistant for ag extension agents in Bihar, in this district of Gaya, and then use a combo of photos and local language voice prompts, connect to like data sets like weather from SkyMet weather or market information from government sort of API, and try to answer this query, but don't go beyond sourcing information that was not provided to you. And then I add like some conversational starters of like what are some questions that one could start off with, and then I give it the specific knowledge base that I want it to refer to. This is how it doesn't go like, this is like the RAG kind of element, which is it's not going to the whole general internet worth of data that like ChatGPT is able to leverage. But in this case, it is specifically like these data sets of our Hindi videos library. There's about 1,000 videos here with about all their transcripts and YouTube video links and some fact sheets and NPM shop data. And that's it. And then I can just play around with it directly. And so, yeah, so for those who are interested in seeing how a similar system could be customized for you, we're open to collaboration. For those who are interested in ways that we could work together in the pre-competitive space of thinking about an Agri-AI Commons, we're also trying to set up like a working group with other folks here on today's call. So feel free to click on this link or email at any time. Thank you again. Over to you, Parmesh.
Thank you very much, Riken. As usual, you are really exciting us and motivating us that this is not in theory, it's being applied in practice. So many farmers have started using this. So many extension agents are using it, and we are very happy with what's happening right now in Bihar. The project which I helped design in 2007, I never expected that within 15 years we'll be talking about absolutely different things. And what I like is that you have used different waves of videos and lots of other things and upgraded that. And you're obsessed with reducing the cost and increasing the impact. I think this is what, if we can work on this and really work with smallholders and scale on that, our objective is to make sure that every World Bank project is able to use a chatbot using all the existing information and content which we have created through all the World Bank projects. But when it came to last mile access, we never had access to all the things we had invested in the system. There are still issues of evaluating how rigorous it is and improving the models. But more we develop this, the more we will make it rigorous. If we start not doing it, then we will not be able to do it. And so please ask questions from Riken, and clearly he's available also for collaboration from not just the World Bank projects, but the other projects as well. Thank you very much, Riken. And please ask questions in the chat for Riken now, as you asked for Ranveer earlier. So moving on, I now move to our final presenter, David Potter. I hope I'm pronouncing your name right. Please correct me if it's wrong. David is a serial entrepreneur. He's with Grow Indigo and Dell Labs and all. He's done a lot of interesting things, and he leads this eclectic group of geoanalytics, enthusiasts within BCG. and it's developing very interesting applications as you go forward. David, over to you.
I like that eclectic group. I think we'll take that label. Good to meet everybody tonight. Let me, and thank you for the invitation. It's really exciting to be here. I think you asking me tonight is actually pretty complimentary to what we've heard so far from Ranveer and Rikin, in the sense that I'm going to shift scales on us, and I'm going to talk a lot about satellite imagery tonight. Although I'm coming away from those two talks and I'm starting to ask myself, do we need satellites to get this stuff done? I think so, but I'm a little bit partial because that's my training. Let me go ahead and share. And if I did that right, you're looking at a full screen view. Great.
Yeah, okay.
Good. Good. Yeah. So as was said, I'm a part of the Boston Consulting Group. I'm in the digital design group at BCG. It's called BCGX. And that's about 3,000 people globally that do tech design build for clients all over the world. And I just rejoined BCG, boomeranging back from startup land. I built a venture-backed startup called Telus Labs, where we did caused a lot of trouble around crop yield forecast, good trouble mostly. We sold that company to Indigo Ag, where we started pioneering carbon farming programs. And I left Indigo about a year ago to come to BCG and build cool tech in the agri space. And so what I want to talk about is what we call Earth intelligence. We think about that as the flow from perception, thinking, and acting. And we're going to talk mostly tonight about the perceiving and thinking part of the flow because Gen AI has just been such a game changer. I mentioned the center that I lead, a lot of really creative, excited folks who are really, committed to a mission around trying to bring AI and other kinds of technologies to help power, the sustainable food transition. And we get to do that kind of work all over the world with participants up and down the food value chain. So tonight I had 3 stories to tell you, and I know we're running a little behind time. I'll try to go really fast, but I won't cut one of them because I think they're all pretty fun. So the first story is about using the segment anything model that was released out into the wild from Meta. I'm not sure how many of you on the call have heard of or seen that model. It's pretty fashionable now, actually, to use segment anything for lots of what I would call off-label uses beyond what Meta had in mind. And I'm going to show you one that's really relevant to farming. The second thing I want to talk about is democratizing access to ag intelligence, but at a different scale, looking at really the food security question of how we can kind of demystify and use large language models to get access around what's going on at continental scales around harvests that have the potential to move the global food system and food prices. And the last thing, if we have time, this is the one that might get cut given I want to make sure we have some time for some good dialogue with our discussants, is seeing those two things in action at a farm level. I think with that, I want to hop into the first use case. So segment anything model, if you've seen this thing before, probably what comes to mind to you is labeling cats in cell phone data. So this is a released out in the wild foundation model. So this is a Gen AI model that was trained on more than 1 billion labeled images from the team at Meta, Facebook. And you can imagine lots of applications for a foundation model that essentially takes a bunch of the friction out of the labeling problem of dealing with imagery. And some of these foundation models, like Segment Anything, are behind the hood in some of the multimodal applications that we saw earlier. So we did not use Segment Anything model to label cats. Oh, actually, we did. It was pretty fun. But in addition to doing that, we decided to do something pretty unusual at the time. We did this kind of work in this sort of April, May timeframe. Like I said, you can check out a lot of great posts on doing this kind of stuff. If you just Google SAM and satellite imagery and farming, you're going to see some cool stuff. I really like the work that DevSeed did in particular. I can share that link after this. When we did this work, we essentially fed the ecosystem of APIs that are released in the open for non-commercial use for R&D by Meta, these kind of images. So this is a multi-temporal EVI image of vegetable fields in the Central Valley in California. And so the colors look so strange here because what we've done is we tried to compress a lot of information into this image. We did not just take satellite imagery straight from a spacecraft and put it into Facebook's work. We really obsessed about data quality. We made sure it was cloud free. And what you're seeing is color is time. So The red is early season, blue is mid-season, and green is late season in this RGB. And that's a great way to compress a lot of information about the farm practices that are happening at an individual field level. In my startup, Telus Labs, we worked on this field labeling problem for several years. We spent millions of dollars of venture money doing a lot of fine tuning of CNN models, convolutional neural network models. And if you've played with those before, they have a lot of knobs and buttons. And there's a ton of expert work and contextualization you have to do to get those things to work. If you train them in the Central Valley in California, good luck trying to run them in rice fields in Vietnam. It takes a lot of manual labor to make a CNN work well. So we wanted to know what would happen with these kind of zero-shot models. And the beauty of a zero-shot model is you don't do any labeling. I mean, essentially, you show it unwarned imagery, and it's drawing on those foundation models. So I'll just cut to the chase. We were really excited. So what you're seeing here is model performance. I'm going to show you some examples of what this looks like. But the left-hand side is UNet model. That's a convolutional neural network segmentation model that was really designed around medical applications and medical imagery, but it's a very common CNN tool for these kind of problems. Higher numbers are good in terms of accuracy rates. On the right is what we saw with SAM. So just to put some context in this, I spent 2 years in a venture context working on this problem. Our team spent about 2 weeks on the UNet tuning to try to get it to look reasonable. With Segment Anything model, we spent 24 hours. And this is the way this stuff actually looks. So on the left are human labeled farm polygons. So that's truth for an area in the Central Valley. Here in the middle is UNet. You can see it could do better. And my experience is with another month of work, we could have made this much better. We could have made it more generalizable throughout California, but it is a lot of compute and human labor to make this stuff work well. And here is Meta's Gen AI model right off the shelf. It just blows us away. And so, maybe the next question you might have is, does this stuff scale, right? I mean, because the reputation around some of these, especially image-based Gen AI models, is the computational intensity is really heavy. So we asked that question, how well would this scale? So we took it from that little region in Fresno to all of the Central Valley. And then we did the entire state of Iowa. So almost 150,000 square kilometers of farmland, 200,000 farm fields. And again, sort of 24-hour-ish compute. These were big problems that would have required a lot of high-performance compute pre these foundation models. And this is just an example of kind of what it looks like. You're looking over my shoulder now. If we have time, I can demo some of this like Ricken did. I think that's more fun, but I want to be swift about this as well. So we're really pleased. I mean, they're not perfect, but these are the kinds of field boundary models that you could use kind of right off the shelf. If you think about it, a lot of the things we've seen tonight, having a barcode, a unique identifier for each farm, it's a difficult problem statement for larger farms, especially. And so coming out of the gates with a credible field boundary is just a big unlock for a lot of application areas, including the next one I want to talk about, which is crop yield forecasting. So I've done a little bit of crop yield forecasts in the last 7-8 years. More often with traditional machine learning models. We decided to give it a shot at BCG, and we've begun some experimentation with transformer models. What you're seeing right now is our XGBoost results. This is a forecast system for 100 million acres of corn and soy in the Corn Belt in the US. So this is a good fraction of the world's corn and soy production. And what we did is we trained on 20 years of USDA actual data at the county level. And this is a live operational system. So you're looking at sort of the forecast that shipped a few days ago. We do corn and soy. We can go down at state and county levels. And the real core of this is an Earth engine that's sort of, it's built on Google Earth Engine, and it's receiving all of the plant health information about how happy these crops are looking, precipitation, temperature. You could compare here the plant health curve, and that's EVI, Enhanced Vegetation Index, against a really bad year. That red line was 2012. So cutting to the chase, how did we do? This light green line is the USDA public forecast that gets updated on the 12th of each month throughout the growing season. And the dark green line is a daily operational forecast. So not once a month, but every day from the team at BCG. And we did this as a public demonstration project this summer. And it's a lot of fun when you're in the forecast business. You're either really right or really wrong in a very public way. And I have to say, we're pretty delighted with this result. So if you kind of squint there at your screen, you see that we essentially got to consensus around the 175 number, which is where USDA is now, a full 3 months sooner than the USDA. And what we're excited about here is just, the reason I wanted to bring this one to the table is we're just starting to test what transformer models are doing. So a truly Gen AI approach on this. And this is still using XGBoost as the core predictor. So my sense is that we're at a threshold moment because of the ability to use Gen AI to get to field level training data, and then using things like Gen AI transformer models for the prediction. We're in a place where the kinds of food security and commodity volatility information that only some of the largest companies in the world have been able to do in the past, I think this stuff is coming out into the wild really soon. In the same way that we saw at the farmer level around democratization of access to agronomic data, I think what we're going to see is democratization to access around commodities data to help farmers sell and buy grain better. And one way to work on that problem is to strap everything I just showed you into a large language model format. And so we couldn't resist doing that. Please, Crop GPT is just a fun internal name. This is built with ChatGPT under the hood, but that logo is just something we use for our own R&D effort here. And I wanted to show you what this thing looks like. It's like what we've seen a lot of tonight. It's a RAG-based model, so we're using that retrieval type approach. This is not benefiting from fine-tuning. What we did is we trained ChatGPT 4 using thousands of documents from the USDA, the National Agricultural Statistics Service, the WASDE. We provided a ton of tabular data on historical crop outputs for the last 20 years, SEC filings from important agricultural companies, and the earnings transcripts from the CEOs of those companies. All of that went into the RAG model, and we used an agent-based model. So we allowed our agents to retrieve data from each of those data stores in a different way, and we actually reveal the way those agents are thinking when we share results. So here I am asking the question, how has John Deere's climate strategy changed over the past decade? And this allows you to look inside the brain of these agents. So it asks itself, what would be relevant? And it does summary against those different types of documents in different ways, and then assembles a heck of a credible answer. And then the next question we're going to ask is, what's the outlook for corn this year? And this one's really fun in the sense that our agent actually built SQL queries and assembled tables of data that inform the final answer, and then wrap that all together, summarize some of the intermediate documents, and then put together a really credible answer in the end. We're really excited about what happens when you start putting these kind of systems in touch with live environmental data like that forecast system that I showed you a couple minutes
David,
ago.
I'm sorry, I'll have to ask you to wind up in 1 minute.
No problem, no problem. Well, in that case, I'll have to just leave a little bit of mystery around what this third application area is, and I hope we have a good conversation here. Again, thanks for the opportunity, Parmesh, for tonight.
Thanks a lot, David. So we'll invite you again because this is not going away. This series is very popular. It has attracted 600, 700 registrations from every part of the world and good participation. So I think we will invite you again to have a version 2 of this, what you were not able to present. So many thanks. This is also very exciting. Farmer Chat, Crop GPT. We are really finding new lingo and terminology of new kinds of applications which are going to come. So I think please keep on asking the questions. We'll extend the session by about 10 minutes to do justice to the rich discussion which is happening. If it's okay with you, you can vote with your feet. If I see the number dropping drastically on the right-hand side, then I'll take another strategy there. But please keep on asking David questions in the chat, and David, please respond in the chat so that the conversation continues. I will now go to our 3 discussants. First is Harsh, who is our global lead on disruptive technology with our environment, natural resources, and blue economy. Is original thinker, doer in the bank on this. Harsh, over to you.
No, thanks a lot, Parmesh, for the invite. And it was excellent to hear all the three presenters, Ranveer, Rikin, and David, on, I think, the excitement they bring in terms of the use of these new technologies. And this is something that we are trying at the bank to see how we can help promote this excitement both within our bank staff as well as with all our clients that we're working with, both in the public and private sector. On overall AI, we know that there's many potential benefits, many challenges that need to be addressed along the way, and so on. The big areas where we see a lot of these benefits are in terms of filling in data gaps, trying to improve the analytics, improve forecasting at scalable levels, as we've been talking about here. And each of these little, even the micro aspects that all of you have been talking about could make a big difference in terms of, let's say, automatic field boundary generation, even while waiting for farm registries to be put together and so on, could make a big difference in the way the data is analyzed and presented to people. And in terms of using geospatial AI for classification, object identification, and so on as part of these is something that we're also trying as part of our bank geospatial platform, and we'd like to work with all of you in terms of doing these a bit more. But I think it's things that a lot of you also mentioned in terms of these chatbots, especially Rikin. I think that I think could be a really good way to try and see how we can explore not only the use of generative AI as we've traditionally seen, but for actually accessing data as well. So to have a data chatbot related to agriculture, related to water, for different types of users, as we saw over there with kind of a woman farmer, or if you're a lady who's heading the water department in some place, or the agriculture agencies and so on, or private sector working on these. How can you go in and leverage a lot of this open data and services, or even subscription data and services, to be able to do more with a lot of the new tools that we now have at our disposal? I'd like to mention quickly, finally, an idea that we've been trying to work on at the bank, working with Parmesh and others, as part of our new digitalization type initiatives, which is on something we call the Livable Planet Open Data Initiative. So the idea here is to try and see if we could play a role in trying to put more data in the public domain. And here data could mean anything. It could be river flows, which are not really well shared, soil moisture levels, it could be the kind of photographs that Rikin and others showed, which could then help train other AI and other modeling tools which are out there, so that you can then develop a range of services in the public domain, which could be everything from early alert systems, could be on floods, droughts, pests, a whole range of these kind of systems, which could then be integrated into planning and operational decision support tools as well, whether it be for small watersheds or large river basins, or for water infrastructure operations, or disaster management, or insurance, or other types of systems, or to just provide insights for different systems as we are looking at, or digital MRV type systems to be able to leverage these. But the key here is to try and see, can you use these for outreach and advisory services, even for the poorest? As it was mentioned, traditionally we've looked at these as systems for the richer folk, right? So can we start thinking about how we can start doing these even for the smallest farmer everywhere? And I'll take 30 seconds to end in terms of showing you two quick things. One is, I'll paste this in the chat. There's a bank geospatial platform. Please do check these out and let us know if there are other data sets we could leverage to try and show you, what the power of geospatial tools and AI could be. But also an example from the water side, where you can say, look, which is there for the Western US. Imagine if this could be done for the world, and really there's no reason why it can't be, for any farm anywhere in the world, in Western US right now. You can say, for example, what is the open ET partnership is put together in terms of what the evapotranspiration looks like in the graph on the right. Imagine if you could also do this for any farm in the world for not just evapotranspiration, but for looking at crop yields or rainfall or other types of pests or other types of information that's out there with other geospatial data that's measured out here and showcased. So these are the kinds of things which we should try and see if we can not only dream but make a reality. In terms of having every smallholder farmer, you could e-package this into little apps on the mobile side and so on, where people could get access to these kinds of systems and leverage a lot of these global data services as they're being developed, including subscription services, which hopefully will be low cost as well. And this is where we are trying to say, can we make accessible more in situ data that could then help leverage a lot of these services and make them much faster, better, cheaper as time goes by for water, for agriculture, for environment, for a whole range of these different services for going towards a livable planet, as we are talking about. Back to you, Parmesh. But thanks again, excellent presentations, and we'll also connect you with some of the various programs that we are financing around the world who've already shown interest based on your presentation. Hopefully, you can work more with them as well.
Thanks a lot, Harsh.
I love that example, and I just want to make the comment that that OpenET thing is really inspirational. And one of the things that underpins it is the USDA cropland data layer. So for the 15 years now, Dave Young at USDA has been building 30-meter accurate crop maps, and they just released crop boundaries about 3 months ago. And so to me, the point you raise also raises the question, how can we use these Gen AI technologies to close the gap between, programs like the USDA program, which is, I don't know how many millions of dollars over how many years to create that base layer data that's being drawn upon in places where that data isn't there.
Thanks a lot, David. So this discussion continues because for your information, we are investing almost now $1 billion on data platforms in many countries. And clearly the trick is not to invest traditionally, but bring AI functionality from day one into that so that we are not starting from ground zero. We could really be very disruptive in the way we create these systems in new countries where we are investing. So I think we will enter this dialogue at some stage, where a lot of you who are here could be potential collaborators on expanding this to more geographies there. Thank you very much. I will now turn over to Stewart Collis, who leads the Digital Agriculture Program in Gates Foundation. Again, a very important partner and collaborator in many countries with us. Stewart, over to you.
Thanks, Parmesh. I'll keep it super brief. But yeah, I mean, no need to revisit all the solutions that were shown today, just additional examples of just how exciting this technology is. I mean, Bill has written about, personal assistance and the transformation that we expect to see with these types of models, the generative AI, LLMs, and specifically transform models. But I think with David's example, we see that, it's sort of beyond just language. It's also other types of data that these transformer technologies can be applied to. So, in addition to imagery, we're seeing some examples in the genomic space or, with the multimodal functionality that Rikin and Ranveer both talked about. Well, that can be applied to, somebody taking a picture of a plate of food and getting an assessment of what nutrition looks like. So there's many applications. I think, I'll get to the points that I wanted to make, and that is, I think, what does this all mean? I mean, it's some ways it's, access to knowledge and information and synthesis of massive amounts of information and data that we can take advantage of, and delivering that in a very streamlined way for smallholder farmers to access, overcoming these barriers of digital access. If you can overcome these, barriers of digital literacy, language literacy, where somebody can, as Rikin showed, can be speaking in their native language and access information and services. I mean, you can increase productivity, you can increase incomes, and these are all things that need to happen, with climate adaptation being a huge challenge. How do we increase productivity without increasing land area that's being used for agriculture, dealing with mitigation, dealing with environmental impacts? I mean, these tools really can, when you add them up, make an enormous difference. So, what we have been thinking about, and we collaborate with everybody on the call here on these topics, is what should we do next? I mean, Ricken and Ranveer talked about validating models, making sure they're working, doing it responsibly. We want to mitigate risks, hallucinations, and all of those issues. So I think that's one area that we've got to keep a focus on. The other is like, how do we make sure that we're leveraging the huge investment happening in Gen AI? I mean, the reality is that this is being driven by big tech companies. And so I think partnership with those companies is about 24 billion going a year into just AI startups in the US alone. There will be open source versions of these, and we need to be mindful of that and engage with those as well. But I think the approach we're taking is, yes, we need to sort of be responsible with AI, understand how it works. We need to engage with all sorts of actors that are building open source and proprietary models. But I think the key is data. We've got to make data available. Today, smallholder farmers are not represented in these large language models. How do we make sure that our data is AI ready? The investments you're making, Parmesh, how do we ensure that that is consumed by OpenAI, by Bard, by Falcon, by any open source model? Because I think if we don't do that, smallholder farmers will be excluded. They will not be represented in these data sets. The work that Ricken's doing, Ricken can only do so much as Digital Green. This is going to take a collective effort. And that, I think, is my final call here is, Ricken mentioned this idea of a commons, but, and I'm not sure what the right solution here is, of a data trust or a global effort to bring this type of data together. But I think something around this could be really, really powerful and allow us to leverage these models to the maximum degree. I mean, ultimately, this is a step change in technology innovation, and how do we leverage it as best possible and make sure it's inclusively accessible. Over to you, Parmesh. Thank you.
Thanks a lot, Stuart. I think I was in a conversation with Rockefeller about 3 years back, and we were talking about algorithmic justice for smallholder farmers. Exactly the topic which we're talking about right now. So I think there is this inclusion aspect into all the AI, generative AI work in agriculture, which we do, which I think we will have to build in, and then the commons or whatever the trust we are talking about. But I think there is scope to do both the things which are developing products, and then also the part which is how do we invest in, I would call that digital common infrastructure, AI infrastructure, which we will have to invest in. I think institutions like the World Bank will have to put in resources to get that thing going, because it's not in the private company's interest to do it. So Gates, us, and some other people who are interested have to develop a collaborative effort to really invest in this architecture. It will require investment in a data and a kind of a infrastructure which to accompany the applications there in future. But very important point, Stuart. So we're running a little bit out of time, but last but not the least, I'll go to Sweta Koluri, who is the head of experimentation at the UNDP Accelerator Labs. A very good designation, Sweta. I wish I had a designation like yours, but please go ahead, Sweta. Floor is yours.
Thank you, Parmesh. Thank you for inviting me here. And what an exciting webinar and super insightful presentation. So thank you, Ranveer, Rick, and David. You've really showed us how generative AI can be extremely helpful for agriculture. And Ricken, your example of hands-on experience of working with small farmers is very, very encouraging. Well, we see that, we have already seen that conversational AI has a lot of potential. I'm thinking more from the gender and women perspective, because at UNDP, we are primarily concerned about the millions of rural women who are not connected to internet yet, and they don't have smartphones. They also lack capacities in terms of accessing internet. Hence, there's a huge opportunity gap as well. In agriculture, we are again focusing on women farmers with bare minimum or no literacy. So here, thinking through the generative AI space, I was wondering if they can leapfrog in the digital economy with generative AI. There seems to be a lot of potential, but is it safe? Will it be biased? What about the false information, and how do we treat the edge cases here? Sorry, my reflections are coming in terms of a lot of questions, but please think through of them as considerations. So can we make LLM also write gender inclusive sentences? Are we proactively measuring gender bias at all? So I would like to hear more and investigate more in that particular space. With simple embeddings and, we are seeing that there is a lot of low code, no code applications coming from the market as downstream applications, but can they fix the bigger problems of misinformation, biases, and data? Of course, Ranveer and Rikin's presentation have shown us RAG and fine-tuning as some of the solutions. But what about the informed consent from the vulnerable groups? What about their personal data protection, especially when you collect the location where the women farmers are located? And given the crime rate in Global South, how do we manage their personal data and also safeguard the personal data? And also, what about the safety? Some of the LLMs are hosted on WhatsApp. A lot of WhatsApp scams are also happening. And how do we actually work this out in a multilingual framework? What about accuracy and relevance? Can we incorporate a smallholder farmer's voice, like Stuart said, in let's say through reinforcement learning or with the sort of human feedback in fine tuning? So, and also great to hear about open source approach Rikin spoke about, and also Parmesh. Many are curating custom databases and customized LLMs for agriculture, but we know that agriculture has very vast knowledge needs and also customized knowledge needs. So each player creating their own database in a siloed fashion is not going to help. And like the other speakers said, we need collaborations. We need to have those reliable databases for AI. So a big thumbs up for digital public good. UNDP and Accelerator Labs are also invested quite a lot in digital public goods, and we are happy to collaborate. We have recently produced a digital public good called Dikra to promote climate resilience in agriculture, leveraging geospatial data, like David has mentioned. So happy to collaborate on this front. Overall, the space is very, very exciting. The possibilities are numerous. But then one top consideration for me is, well, do no harm should overweigh doing good when it comes to generative AI and applying it to the personal data. Thank you.
Thanks a lot, Shweta. And I think this has been a very rich discussion. I think it's beyond me to summarize what's been discussed here. What we are going to do, we do this normally, is that we will curate the chat and we will go back with the chat questions to the panelists and indulge them in terms of responding to some of the issues after the event. And then when we send the recording and the proceedings, even the responses to chat questions will become part of the proceedings, because I think chat is very good. I just want to acknowledge Sarah and Aline are asking the most stimulating questions, because the audience doesn't get recognized. I think this is the best questions award, if we had, goes to Sarah and Aline. They asked the really most engaging questions. And I really feel that all the presenters were also very engaged there. So I would just ask one response before we close down from every panelist, in that sense, the three presenters. So one question is the inclusion question and the data commons question. How do we envisage such a public investment into digital public infrastructure for AI? What would that investment look like? That's one. And the second is about how do we go and do this on scale and not do it in a traditional blueprint kind of way in which we go incremental on this. So just two questions, very quick, 1 minute reflection from everyone. I'll start with Rikin first.
Yeah, I think we need to set up not just a working group, but actually like a group of kind of people who have shared values and are interested in this common idea of commons, and we can create like a governance structure around that. And the last thing I would say is that on the inclusion point, what we're finding is that there's 2 to 3x greater usage by like these bots by women extension agents, by their male versus their male counterparts, because of the greater ability for accessibility and than they've ever had before. So I think there's a real potential here to close the historical gaps that have existed in conventional extension and such.
David, over to you.
I think it's the right inspirational question. I just think about when I want some encouragement on will we overcome for building these public goods, absolutely. Public good is the way to think about getting to where we need to go. When you think about what's been done in medical imagery around massive training databases and the obstacles they had to overcome, if they were having this call 25 years ago, there would have been a lot of concerns around privacy and data sharing, and you could imagine the concerns and questions, and they were able to overcome, and it's transformative. And so I think, you know, if we look to other sectors, I think there's a lot of good encouragement that we can make this work around having common archives. And the other thing I just want to say, like for me, the complementarity on scale was really inspiring tonight, because there is this challenge of some of these remote sensing techniques that I was talking about are challenged as the field size is smaller. And it's not to say that there aren't remote sensing applications for smallholder farmers. There's a lot of work going on there, but it's always been limiting. And the satellites are getting better, but that's going to take time. It's just so exciting to see what's going on with data from places like this, plus Gen AI. And so what I get really excited about is what happens when those things meet in the middle, you know, and I think there's a lot of applications like that coming.
Thanks a lot, David. So I think I would like to now conclude, since we are still at 112 people out of 160.
That's pretty good.
Which I
That's pretty
never
good.
expected when we run 10 minutes away, but I should not misuse that. And just would like to say that we will follow up with many of you. We would like to create a kind of advisory group in the World Bank on this topic, which will include many of you to shape up what kind of investments we need to make to really see this growing, and can we develop a kind of a digital public infrastructure for AI kind of a trajectory, because we end up investing sometimes in things which are not productive. And so what should we be investing in? I take David's point about learning from other sectors which have already done that. I take Rikin's and Shweta's point about being focused on inclusion all the time and asking the question, what happens to smallholder farmers? What happens to women? And because Rikin works with a number of our women empowerment programs like NRLM and Jivika and all, so we have by nature, our target group on this is women quite a bit. And I think we would like particularly people who have been interacting with us on this platform, we will convert this into a distribution list and then eventually an advisory group or more a community of practice, which we would like to facilitate over a period of time. If you have any idea about the things you would like to present on this space, bringing your experience, people talked about carbon sequestration and other things, please feel free to write to us. We will put the email ID, DDA at World Bank. Sunil, please put that email ID there so that write to us. This is a very big community. We have 6,000 people on this network of the webinars which we do. And the AI sessions have attracted a lot of attention because people want to learn and they want to contribute. So we would form an advisory group. We will also continue this webinar series, and feel free to suggest the topics we would like to see covered as we go forward. But we would like to convert this into digital public infrastructure for AI investments in all the World Bank projects going forward. So any ideas you have, please feel free to write to us at the email ID which Sunil has put it on the chat. Thank you very much, and have a good morning, good afternoon, and good evening wherever you are. Thank you very much. Bye-bye.
So much.
Thanks, Rikin. Thanks, David. Thanks, Stuart. Thanks,
Thanks.
thanks everyone. Bye-bye.
Thank you.
Great. Thanks a lot.
Sure.
Take care.
Bye.
Thank you, Parvati.